All right, we got quite a few problems to go over. Is the quiz on Monday or Tuesday? It's on Tuesday, yeah? Anyway, I actually made the quiz and the practice quiz, and I even made solutions for it. I will send them to you, I don't know, soon. Monday probably. Yeah, maybe I'll send it out earlier. So we are in the second half of section 4.2. I thought we were experts already. Apparently not. There's a lot of questions. What? Oh my goodness. 27. Boo! No, no, no. Okay, I'll do it again. Did I or did I not do this example last week? Except it was a, what number was that?
7.
A 7. So in the book it's a 1, so we can't do it.
Oh, sorry, I wasn't here.
Okay, let's do it again then. Anyway, I told you guys this problem is going to be on the quiz. This is one of the 10 problems. So make sure you do the first problem correctly. Make the first derivative, so 2x plus 2y, y prime equals 0. 2y, let's just go straight to it. Y prime equals negative 2x over 2y. Please cancel out the 2's because it makes the next step a lot easier. You don't have to. By the time we get to the test, it's probably going to be x cubed plus y cubed or something. Same problem. Okay, did we get the first derivative? Okay, so then to find the second derivative, you do it again. So the derivative of y prime is y double prime. And then over here, what do you want to leave the negative on the side like an unwanted pet? That's what you guys did one last time. And then I see a quotient here, so you got to use the quotient rule. So low d high minus high d low all over denominator squared we go. Yeah, but Mr. Park, that's not the answer. That's right, because of this. That's y prime. What is y prime equal to? This thing right there. So you have to substitute it in. So you get negative y minus x, y prime is equal to negative x over y, all over y squared. And then you got to simplify this. This is probably the hardest part for you guys. Y plus x squared over y squared. Multiply top and bottom by y, and you get negative y squared plus x squared over y cubed. Now this is the correct answer. However, what did I tell you guys last time? Yeah, so you have to substitute back in, so the answer is negative 1 over y cubed. What? Why is x squared plus y squared equal to 1? Right there, because that's the original problem. So if you don't do this on the quiz, because it's going to be on the quiz now, it's going to be a -1, because you have to be able to pick out the answer on the multiple choice. So this number is not going to be a 1, and you said I used a 7 last time? Was it a 7?
No, I think it was a 4 actually.
Okay, whatever it is. So if that's a 5, then put the 5 there, right? If it's a 10, then you put a 10 there. 37. 37. All right, number 37. We're not going to use implicit differentiation. I guess they put this problem in just to, cleanse the palate. So this is just regular differentiation, yeah? So probably you want to rewrite it like this to the 1/2 power, and then use the product rule, right? Okay, who's got this one? Bailey, product rule advertise it.
X squared plus 1 to 1/2 plus x over 2 times x squared plus 1/2 to the negative 1/2, or x squared plus 1 to the negative 1/2 times 2x.
That is correct. Did everybody get that product rule? And when you take the derivative of box to the 1/2, you get 1/2 box to the negative half times the derivative of the box. Remember now, if you don't multiply by the derivative of the box, it's a -4 right there. It's a fatal error. Because that's the whole thing. That's the chain rule. Okay, now here's the hardest part for you to simplify. Because you're only going to get 2 out of 4 if writing this down. If you want the other 2, you're going to simplify this. So I cancel out the 2's. What can I, here's the first term, here's the second term. What can I factor out? X squared plus 1 to the negative half. You always factor out the smaller exponent. What's going to be left? X squared plus 1 to the, remember we did something like this last week?
1.
1 to the 1. Because when you multiply things, what do you do with the exponents? Don't you add them? Isn't negative half plus 1 equal to 1 half? Yes. Plus, if I factor this out from the second term, what's going to be left?
X squared.
X squared. And so your final answer is going to be x squared plus 1 to the negative half times 2x squared plus 1. Boom! Don't worry, all the problems you're going to get on next week's quiz, the simplifying will be quite pleasurable. Unless it's not. 43. This is multiple choice! 43. If the second derivative is equal to x to the negative 1/3, which of the following could be true? And what are they asking about? Well, one of them says the third derivative. Well, if this is the second derivative, what's the third derivative? How do you take the derivative of this? What do you get? Negative 1/3 x to the negative 4/3. Isn't that the answer then?
No, there's multiple answers.
Oh! This is not multiple choice then. Okay, so that's one answer. I thought it was multiple choice. Okay, so if you know the second derivative, how do you figure out what the first derivative is? You gotta go backwards, yeah? So can you guys go backwards?
Yes.
Because remember, when you take the derivative, you gotta put the power in the front and the power drops down 1, right? So if you go the other direction, the power gotta go up by 1 then, right? So what is that gonna be? X to the 2/3. But then, if I put the 2/3 in the front, it has to somehow cancel out because look, coefficient is 1, right? So when I put the 2/3 in the front, what has to be there to cancel it out? 3 halves. Now is that there? F prime of x is 3 halves. Yeah, but Mr. Park, they got this -3 at the end. Well, let me ask you this. If I took the derivative of this, will you get this? Yeah, because when you take the derivative of -3, you get 0. So actually, they could have put any number here. They could have put +5, and that would be an answer, right? Because the derivative of a constant is 0. And then what about the original function? Okay, well, if you know the first derivative, how do you find the original function? Again, you gotta go backwards. The power gotta go up by 1. So if this is the first derivative, the power gotta be 1 bigger. So what? What's 1 bigger than 2/3?
5.
So is that all it takes to throw you guys off? Just put fractions. That's that. Okay, now you gotta think. When I put the 5/3 in the front, I have to somehow get 3/2. So what number needs to go there? What number do I put here? So when I put the 5/3 in the front, you get 3/2. Somebody said 9/10. Does that work? Yep, it does. So is that there? Yep, that's B. Yeah, but Mr. Park, B got -7. And again, when you take the derivative of a number, you're going to get 0, so you don't need to worry about it. Yeah. Or, of course, what's another way to do it? How about just take the two derivatives of B and see if it comes out to this answer here, right? That's also another way to do the problem. All right, 43, 45. Okay, we need more room here. What? Just 45 what?
There's only a sign.
Yeah, I'm not going to assign B, because we're AB. Okay, let's do 45. Now in 45A, they give you a graph, this figure 8 looking thing. Like that. And they give you the equation of it. y to the fourth is equal to y squared minus x squared. Now it says at the 2 points that are shown, here's one, root 3 over 4, comma, root 3 over 2, and this other point here, root 3 over 4, 1/2, what does it say? Find the slope. So right at these 2 points, what is the slope gonna be? Well, what tells you the slope of a graph? The derivative. So since it's difficult or impossible to solve for y here, we're gonna do implicit differentiation. Go!
For y to the third y prime equals 2y prime minus 2x.
That is correct. See, that's the key right there. Put all the y, shall I divide everything by 2? Like, do good, 2. Too late I did it. Put all the y primes on one side. 2y cubed y prime minus y prime equals negative x. Factor out the y prime. Equal negative x, and then divide y prime equal negative x all over 2y cubed minus y. There you go, that's the derivative. So to find the slope, I'm not gonna do this, you guys are gonna do this. To find the slope, all you gotta do is plug in these 2 points into here. You want me to do one of them? You're supposed to say no!
The first one was
The first one didn't come out.
root 3 over 4, root 3 over 2.
Okay, let's try. If I plug in, so you get the slope over here, let's do it here. Slope is negative x, so negative root 3 over 4, all over 2 times that cube. What is root 3 over 2 cubed? 3 root 3 over 8, my pretty, minus y, which is root 3 over 2. Why, we're having problems simplifying that?
Yeah.
2 over, it goes into 8 4 times. Now, how do you simplify when you have fractions within fractions? Multiply top and bottom by the least common denominator of all the fractions you see. So, what are the denominators? 4, 4, and 2. What's the least common denominator? What? Rhymes with more. 4. So, multiply top and bottom by 4, so you get negative root 3 on the top. Now, when you multiply 4 times this, the 4's cancel out, and you get 3 root 3, minus 4 times this, 2 root 3, so you get negative root 3 all over root 3, negative 1. That kind of looks like a slope of negative 1, yeah? So the hardest part of the problem is you gotta plug in numbers and simplify. See, I told you guys, calculus is easy. It's the other stuff that's hard. I didn't think it was simplifying though. Anyway. Okay, next. What do we got here? 450b. 50. Okay, this is the other example I did on the board last time. Good thing I do these examples, yeah? This is on the quiz. This problem is on the quiz. What is this graph again? You guys remember? It's a tilted, I don't know which way it tilts. Does it tilt to the right or does it tilt to the left? No one knows. I don't know, it tilts one way. Anyway, what are we finding in this problem? Find where the tangents are parallel. So this is the same examples I did last time. Okay, the first step is to make sure you get the correct derivative. So, implicitly differentiate. You know it.
2x plus y plus x y prime plus 2y prime.
Okay, good. Now, can you guys just look at it and write down the answer already? Remember I told you? Look, these are the y prime terms. You're going to leave it on this side of the equation. These two get sent to the other side. They get sent to Siberia. They're going to do x minus y. And then you factor out the y prime and you get x plus 2y, and then you divide. Whatever, I don't care. You just got to get there. Now, in part A, I forgot what they asked me already. Part A, where is the tangent parallel to the x-axis? That means horizontal. So, which way do you think? Okay, let's try this one over here. If it's going to be horizontal, see, there's 2 points over here. You're going to have to find those 2 points. How did we do it? What is the slope of a horizontal line? So here's the derivative. What will make the derivative 0? When the numerator is 0. So what you do is you set the numerator equal to 0, solve for one of the letters. Which letter looks easier to solve for? So y equals negative 2x. And what am I going to do with that? You plug it back into the original. So let's do this. You guys just roll up your sleeves and go to work, man. Plus x, y is negative 2x plus negative 2x squared equal to 7. See, this is the book problem. When the book has problems, they make it ugly. When I make a problem, I make it come out nice. X squared minus 2x squared plus 4x squared equals 7. 3x squared, this is horrid. X squared equals 7/3. So that means x is plus or minus root 7/3. That's ugly. So what are these? See, there's 2 points like this. So give coordinates now. Root 7/3, negative root 7/3. How do I find the y coordinate? Where should I go back to? This big ugly thing or this small nice thing there? Yeah, just go back to this one here. The y coordinate is simply negative 2 times the x coordinate. So whatever you get for your x, just multiply it by negative 2, no matter how ugly it is. Although it's not going to be ugly the next week. Multiply that by negative 2, there you go. So those are the 2 points where the tangent lines are horizontal. Okay, part B. Find the 2 points where the tangent lines are vertical. So like there and there. What is the slope of a vertical line? Undefined. So here's the derivative. What would make this undefined? When the denominator is equal to 0. Now on the quiz, I'm only going to give you one of them. I'm not going to give you both. It's either going to be vertical or horizontal. Solve for one of the variables. I think x is easier to solve for. Take this and plug it into the original. And since I showed you A, you guys can finish B at least, right? Yeah. Okay. I'm not going to do that. See, what would have made this problem if instead of putting a 7 there, what would have been better so that the answer comes out nice? 3.
Oh no.
Yeah, 12 up. If it was 12, then you get x squared equal 4, then x equal plus or minus 2. See, it comes out nice. See, whoever wrote that problem in this book, they gave no thought to what the answers are going to come up. Typical mathematicians. All right? Okay, 50b. Let's just do it then. If I take this and plug it in, you get negative 2y squared plus negative 2yy plus y squared equals 7. 4y squared minus 2y squared plus y squared equals 7. 3y squared equals 7. Y squared equals 7/3. Y equal plus or minus root 7/3. So we just figured out the y coordinates. We just had this problem on the BC quiz. You know what they did? They're switching the x's and y's. So anyway, go back to this one. The x coordinate is negative 2 times the y coordinate. So whatever the y coordinate is, multiply it by negative 2. Multiply that by negative 2. There you go. I don't know, for some reason they had it switched. Come on, man. The x comes first and the y comes second. 61. Multiple choice. 61. It says use the curve x squared minus xy plus y squared is 1. Which of the following is equal to dy dx? All you gotta do is do implicit differentiation. Mariama?
2x minus the quantity. Of y plus xy prime plus 2y prime equals 0.
That is correct. So no need question mark anymore. Yeah, make sure you put the parentheses there, because that minus sign needs to be distributized. So this minus sign gotta be distributed. And then look, here are the two y prime terms. Banish these two to Siberia. So you get y prime equal negative 2x plus y. And then when you factor out the y prime, you're going to get negative x plus 2y. And then you just pick out the answer. What number is this? 61. Let me pick out the answer. Negative x. Oh, so you know what they did? They multiplied top and bottom by negative 1. Is that going to throw you off? Multiply top and bottom by negative 1. Like that. Now can you pick out the answer? No, they didn't do it. They just left it like that. That's it. That's the answer. The answer's A. But then you somehow, what if they did multiply top and bottom by negative 1? You gotta be able to pick out the answer. 64. Which of the following is equal to the slope of the tangent? Are you guys just putting it on because it's even? Why do I even ask questions? Somebody tell me. Okay, let's see if you guys even remember what this graph is. Let me just call on somebody at random. Okagawa, if I were to graph that, you would get? Yeah, it's a hyperbola. That's right. And do you guys remember how to graph hyperbolas? You guys spent the whole 2-3 weeks on it last year. What's the center? 0, 0. This is like over 1 over 1. So what does that mean? What does this 1 mean? You go 1 to the right, 1 to the left. What does that 1 mean? You go 1 up, 1 down. You make the rectangular boxes. This all coming back like a bad dream. You draw in the asymptotes. And since the y comes first, is it left and right or is it up and down? 50-50 chance. It's up and down. Right. So the hyperbola looks like that. You guys didn't do hyperbolas last year?
I think
So-
it's
Okay, algebra 2 then, algebra 2b.
Probably.
Anyway, at the point 1 root 2 right here, right at this point, you're finding what is the slope right there. Anyway, yeah, you don't need to know what the graph looks like, you just gotta be able to do it. So, let us compute the slope, which means we gotta compute the derivative. So implicit differentiation, who's got this one? We talk it.
2y prime minus 2x.
Yep, divide by 2. So y prime is equal to x, y prime equals x over y. So the slope is simply the x coordinate divided by the y coordinate. So what is this divided by that? 1 over root 2. There you go. And then pick out the answer. C. And QQ 2 and 4. Oh. Well, good thing today's lesson is easy. Suspiciously even. Somebody told me they give you all the answers for the QQ. Is that true?
No.
Only the odds. Oh, then it's not suspicious then. Or it is suspicious. 2x squared minus 3y squared equals 2xy minus 6. What is the slope at the line 3, 2? Come on! That's like this problem. Take the derivative and plug in 3, 2. That's all you gotta do. Okay, who's got the first step? Morioka.
4x minus 6y prime equals 2y plus 2x prime.
Yep, that's correct. Shall I divide everything by 2 to make the number smaller?
Yeah.
You bet your bippy I should. Okay, now, put all the y primes on one side. Which side do you want to put them on? The right. To the right, to the right. So that's going to be x, y prime, move that over, plus 3y, y prime. Move this on that side minus y. Factor out the y prime, divide, you get 2x minus y over x plus 3y, correct?
Yeah.
Now, all you have to do is plug in 3 for x and 2 for y. So what is that? 6 minus 2 over 3 plus 6, which is 4 over 9. Box that, that's the answer. Is that a multiple choice problem?
Yeah.
Okay, that was straight. Now number 4, the reason why I like to give you guys these QQ, because these are actual AP exam problems. Like number 4, I remember this on the exam about 10 years ago. Okay, part A, compute dy dx. Okay, that's easy. Now, a free response question is going to be worth 9 points. Okay, so part A, I'm guessing is going to be 4 points. Or 3 maybe. Yeah, I think maybe 3, not 4. 3. Okay, so using implicit differentiation, I get y.
X plus 2y, oh,
What?
wait. Oh, I'm sorry, 1. Oh, wait, what?
Yeah, 1.
Yeah, oh, no, 1 plus,
Wait. This is a product. You gotta use the product rule now.
oh, 1y versus y squared plus,
Okay.
sorry, plus, x x times 2y, y prime minus 3x squared plus
Yeah.
y.
Okay.
Damn it, plus.
No, it's a quantity now. So that minus sign gotta be
Oh, that is,
distributed.
okay. Minus
So it's gonna be minus.
x cubed y prime. Or 1, or what, y prime. Y prime.
Equals
0.
0. Okay, that is correct. So, underline the terms with the y prime in it, leave it on the left side. These two terms move to the other side. So y prime equal to negative y squared plus 3x squared y, all over, when you factor out the y prime, you get 2xy minus x cubed. Boom! Did we secure the 3 points? Why do I keep asking questions? I don't know why. B, find the equation for the tangent line at each point when the x coordinate is 1. How do I figure out when the x coordinate is 1? You plug it back into the original. What happens when you plug in 1 for x, when x is 1? Plug in y squared minus y equals 6. Can I solve this equation?
Yeah.
Yes, this is algebra 1. Make one side 0 and it factors beautifully. Y minus 3, y plus 2. So y equals 3 or negative 2. So there's 2 places where the x coordinate is going to be 1. 1 comma 3 and 1 comma negative 2. At each of these points, you have to write the equation of the tangent line. Okay, so we already have the points, we just need to compute the slope. Okay, let's see if we can do it. Plug in this point. If I plug in 1 for x and 3 for y, what do you get? You get negative 9 plus 3 times 1 times 3. 9. We don't have to do any more already. That's 0, yeah? Okay, that's it. Okay, what happens when I plug in this point? You get negative 4 plus 3 times 1 times negative 2. I forgot what I just said earlier. Is that minus 6? All over 2xy, 2 times 1 times negative 2 is negative 4 minus 1. That's negative 10 over negative 5. Hey, that's 2! And then just point slopokatize it. Y minus 3 equals 0 times x minus 1. Y plus 2 equal 2 times x minus 1. Good enough. That's part B, so that's another 3 points. And then here, usually part C is going to separate the sheeps from the goats on the AP exam. Are you going to be a sheep or a goat?
Sheep.
Good. Sheep is good. C. Find the x-coordinate of each point on the curve where the tangent line is vertical. How many people got this?
I started it, but I didn't know how to finish it.
Okay, if it's going to be vertical, what is the slope of a vertical line? Undefined. So here's the derivative right here. What would make that undefined? Okay, so if you just write down on your paper 2xy minus x cubed equals 0, you get one of the 3 points right there. Because you're showing them you know what to do. But now, what do you do with it? How do you solve an equation like this? Factor out an x and you get 2y minus x squared, right? Now remember, if something times something is 0, that means either the first one is 0 or the second one is 0, right? Yeah. Now, is it possible for x to be 0? What happens if I take that and plug it back into here's the original equation. What if I plug in 0 for x into the original equation? What do you get? You get 0 minus 0 equals 6. No, so there's nothing from that. But what about this? 2y equals x squared. Y equals x squared over 2. What happens if I plug this into the original equation? You get x times x squared over 2 squared minus x cubed times y, which is x squared over 2, equals 6. Is this a solvable equation?
No.
Yeah, it is. Because what is this? X to the 5th over 4 minus x to the 5th over 2 equals 6. Multiply through by, rhymes with more? 4. So you get x to the 5th minus 2x to the 5th equal 24. Negative x to the 5th equals 24. X to the 5th equal negative 24. Therefore, x equals the 5th root of negative 24. That's your answer. I remember that answer. How many people got it? 3. Okay, by the time we get to the 4th quarter, everybody got to be getting this now. Even if you think you're not doing it right, you see the thing is on the AP exam, you got to have an answer. Because if you stop, it's very difficult to give partial credit. You got to just keep on going until you get to some answer. Okay, what time is it? Oh my goodness. I didn't think that would take that long, but it did. Okay, here is the last section we're going to cover in the 1st quarter, but we're not done with the chapter. We still got like one more section to go, but we're not going to do that. Oh, by the way, did you guys look at the assignment sheet? Here, I want to show you something. Look at the assignment sheet. Where's AB? AB. Assignments. I just want to prepare you for what's going to happen. Okay, here's the last week of the course. Okay, so the quiz is going to be on Tuesday. That's the last grade. Plus the homework now. So this is what's going to happen on Tuesday. We're going to discuss the homework 4.3. I'm going to give you 15 minutes to discuss that homework. So if you think you're going to write 20 problems on the board, and no, and then you're going to hand it in now. It's going to be counted. So don't, like I said, don't think you're going to write 15 problems. Maybe we can discuss 5 problems on the board, and then I'm going to give you the rest of the time to do the quiz, so that you can do a good job on it. But look at the first week of the 2nd quarter. On Wednesday, Thursday, and Friday, I'm going to be at a conference in New York. So you're going to have a substitute teacher. So you're going to be taking the test on Wednesday. And then these two, 5.1, 5.2, 5.3, there'll be videos for them so you can watch that. Maybe you'll get a real math teacher as a sub. Maybe they can teach you. Maybe you won't, then you got to watch the video. Hey, how come it's not up here? Okay, this is what we got to do today. How many derivatives do we know now? Box to the n, and then the 6 trig functions, right? That's what we know how to do, like cosine box, sine box, tangent box, and so forth. But now we got to do inverse trig functions now. So we got to add to our list. So this is what we need to do today. How do you compute the derivatives of sine inverse box, cosine inverse box, tan inverse box, cotan inverse box, secant inverse box, and cosecant inverse box? You need to fill in this list. I don't know if you guys noticed, but did anybody from the website get a list of derivatives? It's on the website, you know. Because after this chapter, we're going to learn, those are all the derivatives that you need to know for the AP exam. And then we're going to have a speed quiz on it too, because it's got to be memorized. So I'm not going to derive all 6 of these. I'm just going to derive maybe 1 or 2 of them. Maybe 3 of them. Let's see how much time we got. So like the first one, how do I find the derivative of sine inverse x? Like if you ever forget on a test or quiz, you can derive it just by doing what I'm showing you here. Because we don't know what it is. Well, ultimately, yes, you want to have it memorized, but how do you do it? Okay, what I'm going to do is I'm going to sine both sides, because we don't know anything about sine inverse right now. So I'm going to sine both sides. What is the sine of y? Duh. And then what is the sine of sine inverse x? X, because they're inverses of each other, right? Remember, if you have two functions that are inverses of each other, if you plug one into the other, the answer is x, all the time. So that's what happens when you sine both sides. Now, can I compute dy dx? Yeah, you just do implicit differentiation, the thing that we're learning. So what's the derivative of sine box? Cosine box times the derivative of box, which is y prime, or dy dx, whichever one you want to write. And then what's the derivative of x? 1. There you go. It's very simple. So therefore, y prime is equal to 1 over cosine y, which is secant y. Except, see, the problem is, when you give the function in terms of x, you want the final answer to be also in terms of x. So how can I change the secant y to x's? Well, I'll tell you. What you do is you draw a triangle for this thing right here. So going back to your trigonometry days, sine of angle y is equal to x, which is like x over 1. So what is sine? Opposite over hypotenuse. So opposite over hypotenuse has to be x over 1. See, the sine of angle y is x. You just draw a picture for that. Use the Pythagorean theorem to fill in the side, which is, let me call on somebody. Myers, Pythagorean theorem. Root?
The square root of 1 squared or 1 minus x squared.
Okay, that's it. And then you just look at that picture and now you can do it. So, what is the secant of angle y? Well, cosine is adjacent over hypotenuse, so what's secant? Hypotenuse over adjacent. 1 over root 1 minus x squared. There you go. That's the derivative of sine inverse x. Okay, but what about sine inverse box? Well, is the derivative of sine inverse box just going to be 1 over root 1 minus box squared? Okay, very good. By the chain rule, no, it's not. You got to multiply by the derivative of the box, du dx. That's what the chain rule is. Yeah, you can use the same formulas, but you got to multiply by the derivative of the box, and it's no different here. Now, I'm not going to derive this one because it's the same thing. You know what it comes out to? It comes out to negative 1 over the square root of 1 minus box squared times the derivative of box. They kind of come in pairs, so it's kind of like easy to memorize. Okay, let's do tangent. What if you had y equal tan inverse box? Or let's just go x for now. Doing what we did in this problem, what am I going to do? What did we do? Tangent both sides. So tangent y equals, what is tangent of tan inverse x? It's x. Then you do implicit differentiation. The derivative of tangent box is secant squared box times the derivative of box, which is y prime. And then what's the derivative of x? 1. See, it's like you do the same thing, except it's just going to come out a little bit different. So y prime is equal to 1 divided by secant squared y, which is the same thing as cosine squared y. Well, we want to write our answer in terms of x. So you go back to this, and you draw the triangle for it. The tangent of angle y is x. Now, tangent is opposite over adjacent. So how can I draw it so that opposite over adjacent is x? X and 1, that's right. Using the Pythagorean theorem, Tanaka, we get square root of x squared plus 1. That is correct. So now, looking at the picture, what is cosine of angle y? Adjacent over hypotenuse. And then you got to square it, so you get 1 over x squared plus 1. That's the derivative of tan inverse x. It's 1 over x squared plus 1. So, if I want to take the derivative of tan inverse box, can I just go 1 over 1 plus box squared? No, you got to multiply by the derivative of the box. That's the chain rule. And if you did it for cotan, it would just be negative. Yes. See how it comes in pairs? You just memorize the first one, the other one's just multiplied by negative 1, easy. Okay, what the heck, we got time. We'll do one more derivation since this is so much fun. Y equals secant inverse x. What's the first step? Secant both sides. Secant of y is equal to x. Okay, do implicit differentiation. York, implicit differentiate. Secant box. Oh, that's part of it. Oh, no, you're trying to impress me. You're trying to throw me off the set.
Tangent y times secant y,
Okay, oh, see, threw me off.
and then times y
Equals,
prime 1.
okay, there you go. So y prime is equal to 1 over secant y tangent y, which is cosine y cotangent y. But we don't like that. We gotta write the answer in terms of x, so we draw the triangle. So right there, draw the triangle. Here's angle y. Now secant is x, so secant is the reciprocal of cosines. Cosine is adjacent over hypotenuse. So hypotenuse over adjacent, we need it to be x, so there you go. And then using the Pythagorean theorem, Okugawa.
X squared.
There you go. Now all we have to do is look at the triangle. Now, look at the triangle. What is the cosine of angle y? Adjacent over hypotenuse, 1 over x. What is the cotangent of angle y? Adjacent over opposite. So we get 1 over x root x squared minus 1. That is the derivative of secant inverse x. However, that's not quite correct. You need to put an absolute value on this. Bonus point for somebody that can tell me why. Did anybody read the book? I don't know if it's even in the book. Yeah, it can't be negative, but why can't it be negative? Exactly, that's why the absolute value is there, because it can't be negative.
Because
like
secant exists from 0 to
Okay, I'll just tell you. Look at the graph. You guys even remember how to graph secant inverse? Remember in the range, 0 to pi? And then you hump right. And then you hump left. Because cosine inverse looks like this, is what I remember. Hump. Now look at this graph. If I compute the slopes, aren't they always going to be positive? Because it always goes uphill. That's why you need the absolute value. But ultimately, we just memorize it, okay? So this is the derivative of secant inverse x. What about secant inverse box? Can I just go 1 over absolute value of box times the square root of box squared minus 1? No, because of the chain rule. You gotta multiply by the derivative of the box. And as you can probably guess, then what is the derivative of cosecant inverse? The negative of that. So we need to memorize 6 more derivatives for tonight's homework, but it's actually only 3, yeah, because the other one is just minus 1. Let's just do one example and we're done. Okay, let's just pick one from the book. Okay, I'll pick a good one. Aha! Did I assign number 2? Oh, wait, I gotta scroll. No one knows.
What is today's date? Yeah, you did.
Oh yeah, now one since I walked over here.
Sorry. Oh yeah, I did.
Okay, let's do number 2 because you guys will write them on the board anyway because it's even now. So let's fall into your web of deception every time. Y equal cosine inverse 1 over x. Okay. So what do I see? Cosine inverse box. That means right here, I'm gonna use that. Okay, let's do it. So just follow the thing. What is the derivative of cosine inverse box? Negative 1 over the square root of 1 minus box squared, and here's the most important part, times the derivative of the box, which is, Hazam Alam? The derivative of box.
Negative x to the negative second power.
Okay, so negative 1 over x squared basically.
Yeah.
Okay, that's correct. Okay, you only get half the points though. Now you gotta simplify this. Woo-wee! Well, negative times negative is a positive, so you get 1 over. Now, what do I do with this, man? Well, you gotta make the least common denominator. See, oh, here, let's just go very slowly then. Okay, can I do that then? Yes, you can. Okay, now, when you have fractions, you gotta make a least common denominator. What goes in the top? Oh boy. X squared minus 1 times the x squared there. Hey, can't this x squared come out of the radical as a? Okay, but you gotta be careful now. You gotta be very, very careful. What is the square root of x squared? And please don't say x or plus or minus x. I think we went through this already. Absolute value of x, that's right. So when this thing comes out of the radical, it's actually the absolute value of x. However, when I write problems, I don't know if the book did it, I would probably give a restriction like this. Anytime there's an absolute value of the problem, I put a restriction so you don't have to worry about it. So, since x is greater than 0, you don't need the absolute value. Okay? Can I do any more simplifying? Yeah, in the denominator, can't this x cancel into one of those? Just in the denominator? Okay, so your final answer will be 1 over x root x squared minus 1. There's your answer. See, so what's the hardest part of the problem? The simplifying. Now, if you were clever though, you would say, hey, can't I simplify that, Mr. Park? Yeah. What cosine inverse 1 over x is the same thing as? Somebody impressed me here. Huh? That's right, secant inverse x. Cosine inverse 1 over x is the same thing as secant inverse x. Why? Okay, look, here's an angle. Let's do a 3, 4, 5 triangle. What is the measurement of this angle? Isn't it cosine inverse 4/5? Because the cosine of that angle is 4/5. Okay, isn't it also secant inverse 5/4 then? Yeah, what's the relationship between that and that? They're reciprocals of each other. That's why cosine inverse 1 over x is the same thing as secant inverse x. And then now, look, hey, that's on the list already. 1 over absolute value of x times the square root of x squared minus 1 times the derivative of that, which is 1. But since x is greater than 0, you don't need the absolute value. Boom, there's the answer already. So again, if you can simplify it before you start, then that might save you a lot of time. But it doesn't matter.